There are a couple of different ways that we can approach question letter E, and I'm going to do so in both ways, kind of intermixed, so you can see some options that you can apply in future questions. The question in letter E asks us to sketch the function big F. So it's important to note that this is not a duplicate of the graph at the top of the page. The graph at the top of the page was little f, and that's not meant to have any visual relationship to big F. So it's important to note to not expect anything that looks like this, because that's not really the point of what the big F function was all about. Big F, remember, was an integral function, and we have no idea what it was supposed to look like. Now, one thing that's kind of important to note is that earlier, when I was making a video for part B and part C, I actually did sketch what I thought big F would look like in the context of words like increasing, decreasing, max, and min. So I'm going to keep my sketch handy here just to kind of see if my instincts were right all along. And if they weren't, then of course I'm not going to worry about it. But it is worth noting that you might have thought about some of these features of the graph of F without realizing that you did. So keep that in mind as you're watching and listening to what I'm about to talk about. Now, the other thing to notice is that big F is not exactly completely foreign to us, because we've done a lot of work with big F in part A. We found big F of 0, big F of 2, big F of 4. Arguably, those are points on the graph of big F. So in theory, if we have like 8 different points on the graph of big F, we should use them. And I'm actually going to start with that, because I'm going to use that to help me get a sense of what exactly big F should look like. And then I'm going to use my answers from parts B through D to confirm that that really did happen. So while I'm going to focus my camera here on the graph part of letter E, I'm going to be stealing a lot of my answers from letter A. And so as to not inspire a seizure and go back and forth from A to E to A to E, I'll ask you to look at your own paper for letter A so that you can confirm where I'm getting some of these numbers from. For example, in letter A, I got that big F of 0 is 0, which essentially just translates to the point 0, 0 that I can put on this graph of big F. And again, I'm going to label, just so I'm clear, this is going to be a graph of big F that I'm drawing here. Now in part 2 of letter A, I had big F of 2 is pi, so that's over 2 up 3.14, so that's just about here. I'll plot that point. I had in part A, big F of 4 is 2 pi, so 1, 2, 3, 4. 2 pi is about 6.28, so 1, 2, 3, 4, 5, 6, and about a quarter of the way up is here. I don't know what this graph is supposed to look like yet, so I'm just sketching all the points and hoping for the best. Now, in the next part, I had that big F of 6 is 2 pi minus 2, which is 6.28 minus 2, 4.28. So 6, and then 1, 2, 3, 4.28 puts me right around here. In part 5 of letter A, I had that big F of negative 1 is negative 1, so negative 1 here. In part 6, I had that big F of negative 2 is negative 3, so negative 2, negative 3. In part 7, I had that big F of negative 3 is also negative 3, so I'll plot that. And then I have that in part 8, big F of negative 4 is negative 2. So that's there. Now I definitely don't really know what I'm supposed to be seeing. I don't know if I have sharp points or curves or anything like that. So I'm going to try to use a couple more inferences to help me make some sense of this picture. First, compare it to what we thought we were sketching when we were doing our line chart problem. We saw something that started out going downwards, then flat, then up, then flat, then up, then down. It does kind of look like that could be happening here. For example, here I am predicting that I had an absolute minimum at negative 2.5. Well, sure enough, negative 2.5 would be here. And it does stand to reason that if the graph dipped back down and perhaps up again, that there would be a minimum value kind of in between. So I could purposely sort of make a sketch, maybe to make the graph look like it really does bottom out there. That seems like it makes sense. In fact, I actually found big F of negative 2.5 way back in part C. That should actually be negative 3.5. I could even add that as a point. Negative 3.5. I could probably infer, rightly so, that that is that bottom point of the graph that I thought I was supposed to have. And then the graph looks like it's supposed to keep heading up again. It looks like it's supposed to go flat at 0, so maybe some sort of like cubic situation or something there. But it's supposed to keep going up until I get to 4. And then at 4, it looks like I'm supposed to hit my maximum so that I can turn back down and head towards 6. So even though I've just sort of lightly sketched it, it seems like my predictions from my line chart could actually have been true. Now, let's read back our line charts to ourselves to see if this actually does sort of fit what we thought. Because if so, I'll start to darken in my sketch and feel more confident about it. We're supposed to start out with a graph that is decreasing from negative 4 to negative 2.5. I really don't know what's happening outside of negative 4, so I'll erase that part just because I can't be sure. But yeah, it does look like if I darken this in, it would indeed be decreasing. So I'll make a slightly darker pencil mark there just to show I feel pretty confident about that. Then I'm supposed to turn and increase all the way to 0. That did seem to be true. It seemed like the graph was supposed to flatten out for a second at 0, so I'll just kind of exaggerate the flattening part so you can see it there, but hopefully you can tell what I did. But then I'm supposed to increase again all the way till I get to 4, so that seems like it happened. Then at 4, I'm supposed to hit my maximum point and then turn to decrease, or go down to 6. So this looks like it behaves according to what the line chart suggested of me. Let's check one more thing though. Let's check concavity. The graph is supposed to start out concave down until you get to negative 3, although it's really hard to tell. Between negative 4 and negative 3, I honestly can't really tell what the concavity is, so I'm not going to fixate too much on that. Instead, I'm just going to kind of keep looking at it and see what I can come up with here. Between negative 3 and negative 2, it's definitely supposed to be concave up. It is clear that that is true. Between negative 3 and negative 2, I can definitely see that concavity there. Between negative 1 and 0, or sorry, between negative 2 and negative 1, it's not supposed to have any concavity, so this was probably supposed to be more of a straight line, which, close enough, looks pretty fine. Between negative 1 and 0, it's supposed to be concave down. We can kind of tell, kind of curves down. Between 0 and 2, it's supposed to look concave up. Not bad. It looks like it's kind of concave up. And then from 2 to 6, it's all supposed to look concave down. That definitely appears to be true. So, in theory, we created this graph using 2 key pieces of information. The facts that we gained from part A, points that we knew belonged to big F, and our line chart information, things that help us confirm the overall shape of the graph. So generally speaking, you will be able to get enough information to create a graph from both the work that you'll do for any sort of area calculations and the line charts that you'll do for the function analysis. In all of the questions on pages 15 and 16, you'll find a very similar blueprint. In page 15, for example, you'll start out with a table of values, which is very similar to the part A on page 14. Instead of having a hodgepodge of questions, it actually asks you to organize your information a little bit better on a table. And then you'll see some very familiar questions. Part B is the same as part B on 14, increasing and decreasing. Part C and D are about max and min, same that we did in letter C, max and min. Then you'll see concavity and inflection points, same thing. Then you'll see something about a sketch, same thing. So again, every question that you'll do independently should harken back to what you saw on page 14. So you can always use page 14 for reference, and you can use all of the information therein to guide your choices on future questions. In essence, every question from page 14 all the way to page 20 is a duplicate of the examples that you just saw here. So hopefully this can serve as an example, and between this and the answer key, you can start to really complete this level of function analysis that ties together everything that we've learned from both first semester and second.